Another method is the secant method. This is not a completely new method. This method is the addition in Newton method, or a slight amendment or a slight alteration in the Newton method. So it's not a completely new method. Is a variation of Newton-Raphson method. What is a recommendation in this method? That recommendation is this is the formula of Newton-Raphson method. In the Newton-Raphson method, we need fx, the first derivative, and the initial gas. Three items are needed, and derivative should not be equal to 0, because if derivative is equal to 0, means your tangent line is horizontal line. So that is the case where the Newton-Raphson method failed, and we cannot have the iteration of the Newton-Raphson method with the help of this. So add a new estimate, and new estimate can be obtained by just calculating a ratio of what? Fx and f dash x. This is the Newton-Raphson method. What alteration are recommended by secant method? That recommendation is that the derivative is not required. Secant suggests us to solve the system by the Newton-Raphson method without having a derivative. So that is a easiness in the procedure. They recommended that without derivative we can find out the new iteration. So how can we, without derivation, we can edit the formula? The very simple step, the simple step is what? By Taylor and Maclaurin series. That can be the formula of slope. Fx, f dash x is what? F dash x is the slope. Slope, all of you are familiar how the slope can be represented. Slope can be represented by y2 minus y1 upon x2 minus x1. This is the formula of slope. So secant suggests us to use this formula. This formula, instead of the 2 points, I have these 2 points like this. Suppose this is the point x and fx. This is the x coordinate, this is the y coordinate. And we have another point. This point is what? This point is x plus h and f of x plus h. So instead of having a point by xy and x1 y1, we have x and x plus h. Now, how slope is computed? Slope can be computed as y2. This is y2. This is y1. This is x2. This is x1. So we have to plug in these values into this formula. Y2 is f of x plus h. X plus h. Minus y1, y1 is fx, divided by x2, x2 is x plus h, minus x1, and the x1 is x. Now x will be cancelled out. You will have what? You will have this formula, which is represented here. F of x plus h minus fx divided by h. So this is the formula of slope. Achha, this can also be written as with the help of iteration. Instead of the new point is represented by xi and xi minus 1. The previous point is xi minus 1 and the new point is xi. So we can write down this formula of slope as f of xi. This is y2 and this is y1. This is x2. This is x1. So y2 minus y1 divided by x2 minus x1. This is the another representation with the help of the point xi and xi minus 1. So what secant did? Secant did nothing. Secant just plug in this derivative here in this formula. The formula of slope is substituted here. So you can see that the formula of slope is here in denominator. This is the formula of slope. And after simplification, because we have a double division here, so that will be multiplied fxi multiply by this part will comes here, and you can see fxi into this by this. Xi is already we have in the formula. So this is the formula of calculating the new iteration using secant method. So in secant method, what you can do, the initial iteration, the function value at the initial iteration, the distance in x-axis, the distance in y-axis. This is the formula. This can be used. So without using derivative, by secant method, we can have the new iteration. So that is the simplicity in secant method. Now this slide comprised on entire procedure of secant method. What are the assumptions of secant method? Two initial guesses are required. One is xi and other is xi minus 1. These are the two initial guesses. Suppose I am saying that this is x0, this is x1. Such that f of xi is not equal to the both values of x will not, fx will not be same at these two. So these 2 points should be like that. If we putting these 2 points at the function will not get the same value. So that 2 points should be distinct point, but these 2 distinct point in such a way that these 2 distinct point will gives us a 2 distinct values of y. If these 2 distinct value of y are not given, then we have to choose another guess. Now these are the 2 different values of y. The new estimate is to be computed by this formula. Xi plus 1, the xi, the function value of xi, the difference of the 2 iterations, the difference of the 2 y coordinates. This is the difference of the 2 x coordinate of the previous guess, 2 previous guess. This is the difference between the 2 y coordinates of the two initial guess. So this slide contains the entire formula and assumption. Now we have one example. In this example, a nonlinear equation is given to you and the 2 initial guess are given to you, 0 and 1. So you have to calculate another guess, xi plus 1. How you can calculate the xi plus 1? So you have to put, suppose I am interested to calculate x0 and x1, I am going to calculate the x2. How the x2 can be calculated? X2 can be calculated, x2 is equal to this is x1 minus fx1 multiply by x1 minus x0 divided by fx1 minus fx0. This is the new entry. The value of x1 is given to you, it is 1. So you have to put 1 here. Minus fx1, you have to calculate fx1. Fx1 is how much? Fx1 is equal to 1 square minus 2 into 1 plus 0.5. So 1 square is 1. 1 minus 2 is minus 1. Minus 1 plus 0.5 minus 1 and plus 0.5. So is equal to minus 0.5. So this value is minus 0.5. And now I am just plugging these numbers here so that you can have the clear-cut idea what will be the next iteration. X1 is equal to X1. The value of X1 is 1 minus the value of fx1. The value of fx1 is 0 0.5 with the negative sign. We have a negative sign here. So minus 0.5 multiply by xi x1. X1 is 1, xi minus 1, x0 is 0 divided by f of x0 and f of x1. So the value of f of x1 is minus 0.5 minus, or f of x0 means we have to plug in x0 into this function. This is called f of x0. F of x0 means 0 is to be plugged in here. So 0 minus 0.25 plus 0.5. So it is 0 0.5. So it is 0 0.5. So the new iteration will be 1. This minus minus becomes plus. This is 1 means nothing divided by this is minus 1. So minus 1 means we have a minus 1 here. And minus 1 and minus 1 will give you 0. The initial value, the next value is given to the 0. So I am just showing you the solution here by erasing the content of the slide. So in this slide, we have a algorithm of secant method in the form of a flowchart. Initial guess are there, x0 and x1, and initial iteration is 1, and the first I is equal to I plus 1. The second x, the value of x is can be calculated by x2. The formula of secant method is there. Error is computed. If error is smaller than the specified number, then you have to stop. Or if error is larger than the specified number, we have to go to the next step and a new iteration is computed. And in the same way, up to a smaller error than epsilon, you will stop. Now we have a comparison of root finding methods, bisection method, the Newton method, the secant method. The bisection method is easy, reliable, convergent. Convergent means we can have, it is conversion, but slow convergence we have in that. Needs an interval AB, these are the initial guess. AB, one interval is given, the root is available if the product is negative. If the product is positive, then means the root is not available and we have to take another new guess. In the Newton method, is better than the bisection method. We need only one initial guess and one derivative is needed. That is the con. We need the derivative because if the complex function we have, finding the derivative will be difficult and time consuming. So another version of Newton method is the secant method, in which the derivative is replaced by the formula of approximation. That is an approximation. The formula of slope is used as a derivative, as an approximation. So in secant method, derivative is not required. That is a feasibility in Newton method, in secant method, but two initial guesses are needed. So these are the comparison among the three methods that we have selected in this presentation. And now we have some examples and we want to cover these examples here in this. Now we have to solve the given equation x6 minus x minus 1. We have to solve this by secant method. According to the secant method, the two initial guesses are given, which are the requirement of the secant method. Initial guess 1 is 1, initial guess next initial guess is 1.5. This is the formula of computing the next iteration. If I put the value of I is equal to 1, this is equal to x2 is equal to x1 minus f of x1 multiply by x1 minus x naught divided by fx1 minus fx naught. This is the formula of calculating the next iteration using the Newton-Raphson secant method. We have to calculate fx1. fx1 is equal to 1.6 square minus 1.5 minus 1, not 1.6, it is 1.5. So you can calculate 1.5 square minus 1.5 and minus 1 and give me the answer. Similarly, I have to calculate f of 1. The value of f of 1 is equal to 1 raised to the power 6 minus 1 minus 1. This is not square, this is power 6 we have. Now you have to calculate 1.56 minus 1.5 minus 1. And this way 1 raised to the power 6 is 1. 1 minus 1 becomes 0. So the answer is minus 1. The answer of the f1 is minus 1. And answer of f1.5 is what?
सर 8.89 है, 8.86 नहीं है.
8.89 है, okay. So this value is 8.89. And we have to calculate the next number. The next number can be calculated by x1. The value of x1 is 1.5. And minus f of x1. F of x1 is 8.89. Multiply by x1 minus x naught, 1.5 minus 1, divided by fx1 is 8.89 minus f of x1 is minus 1. So minus and minus 1 becomes plus 1. So now you have to 1.5 minus 1, it is 0.5. 0.5 divided by 9.89 multiply by 8989, then it is subtracted from 1.5. You have to tell me the answer. What will be the answer after calculation of this expression? On the next slide, the initial guess 1 and 1.5 is there. The initial guess was 1. This is the first value of initial guess. This is the second value of the initial guess. So this is x naught. This is x1. And the new number is calculated. That new number is x2. It is 1.05 as you were telling. Then this is x3. This is x4. And so on. This is x5. And this is x6. So these are the 6 iterations by secant method. And every time 1.5, 1.05, 1.14, 1.3, 1.34. So we are getting to the new iteration in the same way. Error is reduced or increased. You can calculate the error by the difference of these two, the difference of these two, the difference of these two. At every step you have to calculate the error, and you can see if the error is reducing, means we are converging. If the error is increasing, means we are diverging. In this example, we have to apply Newton method or Newton-Raphson method for calculating the root of the function. The given function is x cube minus x minus 1. One initial value is given to you. That initial value is x naught is equal to 1. So we first have to calculate the derivative of the function because for Newton-Raphson method, the derivative is required. For secant method, the derivative is not needed. Now, what is the derivative of this function f dash x? And f dash x is equal to 2x square minus, we have a 2x square here. 2x square minus the derivative of x is 1 and the derivative of 1 is 0. So 2x square minus 1 is the derivative. X cube minus x minus 1 is the function, and initial gas is given to you, and that initial gas is 0. X0 is equal to 1. So next initial gas can be calculated by x1 is equal to x naught minus fx naught divided by f dash x naught. So x now value of x naught is given 1, and the value of fx naught means f1 and f dash 1. This is equal to 1 minus f1, the value of the function at 1. So we have to plug in the 1 here. If we plug in the 1 here, this will become 1 cube minus 1. So 1 minus 1 becomes 0, and minus 1, this is minus 1. So x0 is minus 1. So we have a minus 1 here in numerator. And in the denominator, we have to plug in 1 in the derivative. The derivative is this. So the value of the derivative at 1. The 2 into 1 square is 1. So this is 2. 2 minus 1 becomes 1. So we have 1 here. And that is equal to 1 plus 1. According to the calculation, it is 2. If it is 2, then we have to calculate the next iteration. The next iteration can be calculated as 2 minus f of 2 divided by f dash 2. So in the same way, you have to proceed for the rest of the iteration and calculate the error at the each level. So I am just demonstrating it this in Excel. Now you can see in Excel, the function is x cube minus x minus 1, and the derivative is 2x square minus 1, and initial gas is x naught is 1. This was the value of the initial gas we have. X naught is 1. Now, how the new iteration is computed? Before going to calculate the new iteration, we have to make a column in which the iteration numbers are there. The first iteration 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, the values of fx are to be calculated, and the value of x are there. These are the iteration number. It is represented by I. The values of the function fx are to be calculated, and the value of the derivative is to be calculated, f dash x. And then the new iteration is calculated. New iteration and error. Fx. How fx is computed? fx is a function in which we have to implement the function this x cube minus x minus 1, x cube x, the value of x, this is the value of x. So x cube minus x minus 1. This is the formula. The minus 1 because this number is 1. So I have to put this initial value here. Now x cube minus x minus 1. This is the formula. Now we have to calculate the derivative at this function. The f dash x, 2 multiplied by, the formula will be what? 2 multiplied by x square. X square means 1 square. And then minus 1. This is the derivative. New iteration, the formula of new iteration will be what? Xi plus 1 is equal to xi minus f of xi divided by f dash xi. If I am writing this as xi, xi is in column number B3. So according to the Excel formula, it is B3 minus f of xi is C3. And f dash xi is D3. So we have to implement the formula in E3. How this formula act? This formula act as D3 minus C3 divided by D3. So this is to be the new iteration. So I'm just typing this formula here in the next column. That column is column number E3. Here we have B3. This is B3 minus, in the bracket, I have to write down C3 upon D3. C3 is this, divided by D3 is this, bracket closed. The answer is 2. As I told you the answer in the presentation, I have manually calculated, that answer was 2. So you can see the answer that I have calculated in the presentation manually, this was 2. I'm showing the remaining iteration in Excel in a simple way. Nothing you have to do. You have to copy this new iteration here. So I have to just write down a formula here. That formula will be what? Is equal to the cell reference. So E3 will be the new iteration. So this to be copied here. Now, this is to be, now I am going to copy all of these up to the 10 iterations. Now error can be calculated. How error can be calculated? Error is the difference among the two consecutive values of x. So these are the two values of x. So I have to write down a formula of calculating the error as these two numbers are to be subtracted. This new iteration minus the previous iteration. And I copying this formula so that the remaining error here we have an error 0.00. So I'm removing this iteration because the minimum error is there. Oh. Why it is -1? Because this is assumed as a 0. So this number is to be copied here. Now this is 0.004. So you can see that the error is reducing. 0.0008, then we have 0.0004. Every time we have a smaller value of error. So this is the implementation of Newton-Raphson method in this example. Now there is a correction in the formula of error. That correction is what? Instead of calculating the error by the difference of these two numbers, I am calculating the error by the difference of these two numbers, 1 and 2. So the formula is redefined here. The formula is a new iteration minus the previous iteration. This is 1. And now I am defining the rest. Acha, these values are also be copied. Still we have alternate sign in error. Why? Still there is a correction. And that correction is what? When I am copying this formula here, and the remaining process of copying is to be shown, to that copy should be done first, then this copy is to be performed. Still I am correcting these values and these values. Now it is fine. This is E3. Now I have to copy it. Sorry. This is. Now you have to copy it. And then this is. Then you have to copy it. Still it is in alternate sign, 1 minus 1 plus, but it should be the positive one. So there is some error in this calculation, and we have to focus it again. In the solution of this problem, the error was the error in derivative. Instead of the derivative of x cube is 3x square, I wrote the derivative as 2x square. So we have to correct this, and new derivative is to be represented there. The new derivative will be 3x square. And this new calculation will be changed, and f dash 1 will be 3 minus 1 will becomes 2. So this is not 1, this is 2. And 1 upon 2 becomes 1.5. So this calculation will be equal to 1 plus 0.5. So it will be 1.5. So that was the error, and we have to correct it into the Excel file. And in the Excel file, there is a correction 3x square minus 1. And 3x square minus 1, we have to update this formula here. Instead of 2, I have to write down 3. X square minus 1. So the new value is 2. and the next iteration is 1.5, which is fine now. 1.5. In the same way, you have to calculate. Acha, I am writing one more correction I am doing here. That formula of new iteration I am copying here. Instead of new iteration here, I am just writing the new iteration here, direct formula of new iteration. The formula was what? The formula of new iteration was x this minus this upon this. This is the new iteration 1.5. I am deleting this column because it is no more needed, and error are to be calculated by the difference of these two. Now error is equal to this minus this. This is error. Now this formula is copied and you can see the error is becoming less and we have a 0. Now I am comparing the values 1.3247 with the value 1.3247. The same value we are getting, and the same value is what? 1.325. 1.325 is the value which is the correct value. And this is the end of this example.